Hello, my name is Ryan, and today for my project I chose to do the mechanical leg. So during this presentation, I'll identify different types of joints, how my mechanical leg works, its relation to math, and also the process of making the mechanical leg. I will state some of the obstacles I had to face and also my learning story. So first, I'll start off by explaining what are the different types of joints in the human body. So to start off, there's a ball and socket joint. The ball and socket joint, as you can see in the picture, moves in all directions, and an example of the ball and socket joint includes the hip. There is also a hinge joint. These two joints are what are going to be in my mechanical leg. The hinge joint opens and closes like a hinge, like a door, and it moves in only one direction. And an example of this is the knee and also the elbow. So for my mechanical leg, I use the ball socket joint for the hip and also the hinge joint for the knee. So another joint that I did not use is the condyloid joint. It moves in all directions, but it has no rotation. And an example is the knuckles. As you can see in the picture, that is how it moves, but it cannot rotate. There's also a gliding joint, and as you can see in the picture, it has minimal rotation, but it can do all the movement, front and back, and also left to right. And an example of this includes the ankle and also the wrist. There's also a saddle joint, which as you can see in the picture, it has side to side movement, and an example is the thumb. It's a specific part of the thumb, to be exact. So this is the mechanical leg that I built, and as you can see here, there is a ball which represents the ball and socket joint, and then here is the knee, and later in this video I will explain to you how the knee works and the hinge and also what is behind all the movement. So the materials I use to build my mechanical leg are cardboard, hot glue, toothpick, scissors, ruler, and a pencil. I've used all of these materials to help build the mechanical leg. So when I was making the hypothesis for my mechanical leg, what I knew that I had to make a mechanical leg. It should have a working hip and knee joint, and it should be zero cost, and it should use everyday materials that I have at home, which means that I shouldn't have to buy anything from outside to be able to build this mechanical leg. So its relation to math is, for example, the knee. The knee, when it bends, it can make many different angles, and we can compare that with sine, cosine, and tangent by finding the length of the sides and using those lengths to find the angles. For sine, we use the opposite and the hypotenuse. For cosine, we use the adjacent and the hypotenuse side. And for tangent, we use opposite and adjacent. As you can see in this picture, we can use all of these to find the degree of the rotation of the knee or how much it opens or closes. So my learning story is basically what I have learned during the making of this mechanical leg. What I have learned is I learned about the different types of joints in the human body. I've learned how they work, what are they, and which ones are used where. And I also learned how to make a mechanical leg and what are the different aspects of it. So some obstacles I faced is learning how to build a hip joint, a knee joint, and also finding the math part and building a mechanical leg. So when I was finding the hip joint, I had to look at real world examples, and I also used the movement of my own hip to find out how should a hip joint move. Same thing for the knee, but for the knee, I compared it with the hinge of a door. That helped me a lot math, in doing the math, and also in like finding how to build it. And that's how I overcame the obstacles, mostly through Google, through diagrams, and through real life experiences, and through videos that explain all the hinges and what they do. So this is the final product of the mechanical leg, and so as you can see here, there's the ball and socket joint, there's a ball here, and there's also here the knee. This arc is the knee, and it also bends in the other way, Since a hinge joint only moves in one way, it's like a normal knee. So now I will be doing a physical review showing you how this mechanical leg works. So here's the video review of my mechanical leg. So first, to start off, here is the ball and socket joint. As you can see here, there is a ball and this is the socket. When these two go into each other, you can use this to help move around. And as you can see, it can move in all directions. And also, since it has a hinge joint, which makes for the knee. So I used an example of a door hinge. To get this, there's a toothpick right here that goes through these, and this allows the knee to move, and this knee prevents the leg from moving more than it should. It keeps it at a certain arc that allows it to stay put and not over flex. So here you can see the knee stops at this point, and the ball socket joint can keep moving and rotating as it needs to, just like any real ball and socket joint can. Thank you so much for watching my STEAM project. I hope you enjoyed and learned something new. Thank you.